So what are we trying to build? In the grand sense, we're trying to build a sort of a space-themed MMO because I just think there are not enough sci-fi themed MMOs. I was kind of playing Star Citizen for a little bit, but I was like, well, there's a lot of stuff about Star Citizen that I don't like, and they're not the kinds of things that necessarily would be fixed by a 1.0 release, right? There's certain like ideas that I kind of don't agree with games. As I was thinking, well, wouldn't it be fun if I just, tried to build something myself? But if you think about an MMO, if you go to try to build an MMO, you're probably going to fail. It definitely is the worst the worst possible project for a first game. But in a certain sense, CIG kind of proved that old advice was definitely not true. And there's just been a lot of advancements both in coding and AI and stuff like that. So I started thinking like, well, what if I could make this MMO that I kind of would like to make, and I could use AI to do it. So against anything that could be considered good judgment, I decided to sort of embark on that quest as just a hobby project. And I figure like I've sort of slated it'll probably take like 10 years, and it may or may not be a success. I'm not really too interested in that. I'm more interested in like having something fun to do and learning some stuff along the way. But when you talk about an MMO, you're really talking about a very complex thing. Like everyone thinks, or even when you're talking about a game, just like a regular old game, you are talking about a very complicated piece of software. When you're making anything remotely broad, I mean, if you're just going to make like Pac-Man, maybe it's not super complicated. It is complicated, but not super complicated. But when we're talking about a game, we're actually talking about like a collection of systems, some of which are integrated into the game, and some of which like ship to the end user, and some of which are just actually used in the building of the game. Because just like any kind of like real world construction project, you have to make all these jigs and molds and stuff like that in order to actually make the final product that you're going to make. So making a game is really kind of very complicated in that sense. So I decided, hey, randomly, like, what system am I going to work on first? And one of the systems, because I was recently playing this Dune Awakening game, and one of the systems that was kind of annoying me a little bit was the inventory system. There were lots of things about this that I think are just like clear, obvious bad decisions, um, and sort of unfinished thoughts and sort of unbaked things. And I also found that the people that I was playing with, because I'm kind of like involved in programming, they were also asking me like, "Why is this bug there?" And part of it has to do with all kinds of different ways in which people very mistakenly implement an inventory system. Because if you think about a game and an inventory system, like you're really talking about something that exists in lots of other kinds of software, like a point of sale system or something like that. You've got like this inventory tracking and inventory management. What's going on with the inventory and how is it being used? And also, what I wanted to do is I wanted to kind of like, because one of the things that I enjoy about a game is collecting things and then organizing them in my inventory. Like I get an immense amount of joy with coming up with ways to like organize my containers and all this different kind of stuff, and I have systems put in place and I have like all this thing. So I was sitting there thinking, I was like, actually, like inventory management is a kind of game within the game. And so, what if I just focus really close, really down on just the inventory aspect of this particular game that I think I'm making? I make this sort of generalized system for managing inventory, and then I find ways to facilitate what I consider to be the game within the game of inventory. And the game within the game of inventory is kind of for people who are a little bit, finicky or fastidious, who like everything to be aligned, who like their things to be like alphabetical or by category, who like to come up with categories for how to like organize their stuff, and like all their containers to be in a row and stuff like that. So, how could I make that sort of like that Marie Kondo organization thing to be a way to be kind of like a feature of the game? So I decided I'm going to focus on this inventory system. So if you have an inventory system, um, a naive thing is to just think about this as like a glorified list, but that's really not what we're building. And one of the reasons why we're doing things like little by little, step by step, is because actually the inventory system is a non-trivial subsystem of the game. Now with this inventory system, I'm not going to start by showing you the final form because um, that's probably going to blow your mind. But we're going to kind of start with just a form that's definitely going to be beyond what you think it should be, and then I'm going to explain to you why it has to be that way. So we're going to have a database. We actually don't really care about the database, but it's actually more fixed than most people think it is. And it's actually more irrelevant than most people think it is. I mean, the idea that for most purposes, it doesn't matter. Maybe it'll be MySQL, maybe it'll be PostgreSQL. We don't really care. So once we kind of have this, we're just going to create another thing, and we're going to call this the inventory service. And then what we're going to do is have the client. And the client is kind of going to be like a really traditional client. It's going to be like in C++ or something, whatever. The user is going to be doing some interaction, and they're just gonna make a request to the client, to the service. They're going to make a request to the clients, and then the job of the inventory service, at least in like one case, will be to then take that and make a request back to the database, right? But that's not actually how it's going to really work, because that is a horribly dumb thing to do, because then why do you even have this? Like, why even have this if you're going to just be a proxy for the database? Obviously, what this is going to have is a cache, meaning that, it loads up the necessary inventories to do its work if it doesn't have them in its cache, but otherwise it keeps them in its cache and then sort of responds to the client thing. So why do we have to have this? So first of all, like, this is just a very sort of simple breakdown, and the reason is if you have what would be called an authoritative client, that is a client that can be an authority on anything that happens in a game, to whatever degree it's an authority, cheaters will exploit that to cheat. So if your inventory system in your game, if that code is existing and running and authoritative in the client, like what's in the inventory, which inventory it's in, how many you have, if any of those things are even remotely authoritative in the client, a cheater is going to figure out how to exploit that. Or, I mean, just imagine if the client can decide that you split a stack. Say you have two items and you want to split them into two stacks of one. If you can exploit the client and it can be authoritative and it just saves whatever you did, well, why not just sort of corrupt the code a little bit? And whenever you split, a stack of two into two stacks of one, instead you split it into two stacks of 100. Like, who's to say you didn't have 100 items? That logic is going to have to live in something that is in our space that we control, and what we control is right here. We control this inventory service. The client has to authenticate to get there. They have to make the connection, and then we can control, and it's much more difficult, not impossible, but much more difficult to corrupt the code of the inventory service than it is to corrupt the code of the client. And if we make the interface to the inventory service, which in our example with our project we've been using Thrift, if they don't make a proper request, then it's just not going to lead to anything here, right? This isn't 100% guaranteed, but this is like a better way to design it. Now, obviously, this is not the real final form of what we're going to do. There's a little bit of a problem here. So this is not very resilient. But if you build anything with just one instance, you will always make mistakes that will bite you in the butt. When we build this inventory service, when we run it, we will never run it alone. It will always be a minimum of 2 services. There will actually be 2. Okay? And the reason there will be 2 is because this will always force us, and we will make sure during testing that the client never connects to the same instance of the inventory service. In production, it can. Maybe we can make it sticky. Maybe that's a good idea. We don't know. That may or may not be a good idea. But when we're testing, we are never going to let it connect to the same one, because we do not want to rely on a single instance. Because if, and this is a huge if in this case, because who knows, right? let's say we make this game and it becomes really popular for some reason. I don't know. It goes viral. Wouldn't that be wonderful? I would love that, probably. But that means that now there, instead of having like, 2 people playing your game, because that's probably going to be a realistic number, now you have like 2,000 people playing your game. And they're all opening and fussing with their inventory. And all of a sudden, this woeful little service that you got, well, ooh-wee, it's overloaded and it's going to fall over. And then, of course, your game went all viral, but now nobody can use it because it's falling over all the time and it's really buggy and everyone complains about it. And so the only thing that you achieved by going viral at this point and having all these new users is to have like 2,000 reviews of why your game sucks really bad. This is not even the true final form. It depends. Like, it depends what we're going to do. Obviously, with the inventory service, we don't have to be, with the game server, we're going to have to be, or the game service, we're going to have to be a little bit more crazy about it. With this inventory service, we might not. We might just be able to horizontally scale it. But once we have this, there's a little bit of a problem. So client 1 goes in and makes a change and writes to the DB, right? But then client makes the next request. Remember, the next request is not going to go there. The next request is going to go here. So it's basically going to make that thing, and then it's going to write to the DB. Let's actually duplicate this, right? It's also going to write to the DB. We're starting to have a little bit of problem, because the problem is that the state here, the caching concept of here, is now completely invalidated, because when the client makes another request to this one, this service has to know that its cache is now dirty. It needs to be expired. It needs to go through and load it, right? So how are we going to handle that? Because that is a little bit of a problem, because this inventory service is just going to be like a simple service. We've already seen most of the code. Most of the code is actually written. Like, that's really all you have to do, like transfer item, split item, things like that. It's a very simple service. And most of it's going to be just making sure that the data is in line. So one way we can kind of do that is, and there's a couple of ways. The one is we can make a simple connection between these two services. We have to basically put a two-way tube in between these two systems. Now, the tube is basically, whenever you do something here, you essentially kind of replicate it. You either replicate it entirely, right, which is that whatever the record is here, you just send it to the next guy. Okay, that's like one way to do it. That may or may not, probably will not be the way that we're going to do it, because another way to represent this kind of like this tube here is with something like a log store, like Kafka. Okay, I'm really going to create an inventory service topic. This has nothing to do with clients. They're never going to read this. And what it is that whenever an inventory service does something, it's basically going to serialize the thrift struct, right? That's why we kind of pick thrift into binary data, to bytes. It's going to use the compact protocol or something like that, or the binary protocol serializer. And it's going to basically just stick it on this log store, and just it's going to identify itself as, I'm like inventory service A, and this one down here is inventory service B, and it's going to do that. And they're both going to subscribe to this, and whenever they see a message on this log that isn't about them, they're just going to grab it off and do it. And we're just going to make this so that it's not super persistent. Like, we don't care about it being super persistent. But we just want it to be, we want it to live for a couple of seconds, pretty much. So it's just going to be this real-time queue between these two things. I mean, we could also use like RabbitMQ or something like that. I mean, there's different mechanisms. We might pick one, like, well, which one is actually going to be, but whatever it is. But these need to do that. And one of the reasons why we kind of want to tend towards maybe like a Kafka system is that if all of a sudden we go viral and this service starts getting a little bit overloaded, well, guess what? Guess what we can do? All we have to do, and again, these services don't have to know about each other, because if we do a queue, there's a little bit more involved than doing it that way. They have to know about each other. Guess what? When it comes up, it just automatically gets added into the load balancer, because also remember, yeah, we're going to definitely need a load balancer here. So right between the client and the final system, there's actually like a load balancer. And whenever one of these things comes up, it's going to basically say, hey, I'm an inventory service. So whenever you get a load balancer, whenever you get an inventory request, you can do it to me. And guess what? This guy can just say like, and oh, by the way, I know by some mechanism, we'll figure that out later. We'll just have some registry service. I need to subscribe to this inventory service topic. And the moment it starts getting that, it sees that these guys have both been processing requests, and it just basically updates its memory there. So one of these is in charge of making sure that the database is updated, and one of them is just making sure that these guys have the latest kind of update. There will be some more involved. Like, there will be more involved in this. There's a little bit more about edge cases. We might do some things like locking, so that we want to make sure, because some things that you kind of want to make sure is like, let's say the client makes a request. That request gets routed to this inventory service, and this inventory service starts working on the problem. But the problem takes time to do. But let's say this client either intentionally or unintentionally does multiple button clicks, and so it actually sends more than one request. Well, the first one comes through and it goes to inventory service A, and the second one comes through inventory service B. But how does it know, like, which one gets to decide? Which one gets to be the decider of that request? Because if both of them do the work, what if one of them, and in this case, it's probably not going to happen. In this case, it's probably not going to happen because it's so simple. But it's entirely possible that then we'll have this conflict between the two. And that could be a source of bugs. So we might actually want to implement a locking system that the moment one of them gets a request, they immediately call out to a locking service and they say that, inventory of ID 123 is locked. So that when the second inventory service gets the second request, it tries to get the lock for that inventory to make the commit, right? And it finds out that it can't do that because it can't acquire the lock because it's already locked. So that might be kind of like how we end up doing that. Again, like all of these are kind of like future things. Now, another way to do this sort of thing, we won't need to in this particular case, we might need to when we do like a game server, is actually to make these a series of replicas, right? With a leader. So you have like this one, and then you have like a second one, and one of them's a leader and one of them's a follower. And whatever this one does, it immediately replicates it to the follower of doing it. And if for any reason this guy dies, this guy actually takes over while this guy is getting repaired. So that's kind of another way to do it. In this particular service, I'm feeling like this is probably going to be overkill for the inventory service, right? Because really, we're really talking about like not super complicated problems, because we're only going to be working with the actual inventories themselves and not the positional data, because like the client is going to get that information somewhere else. It's going to get that from the game service or get that from like, sort of like an item service that sort of returns like where are the items at. But this one is all about like the player inventory, how many inventories do they have, what's in the inventory, whether or not it's split, whether or not it's stacked. And so, and again, like you don't have to over deploy it in the actual final analysis, right? Like when we do the testing, we always do the testing with 2, but actually in production, like we could just deploy the 1. Or if it turns out that there's just not enough people and they're not making a lot of requests. But the thing is if you design for 1 and you need 2, you're screwed. If you design for 2 and you only need 1, you're less screwed. And that's generally the experience that I've kind of had with systems design. And so like how and all these like we don't necessarily have to build a load balancer right now. I don't know if we'll use some sort of I doubt we'll use an out of the box system. We'll probably use something a little bit custom made. But we are going to have to build basically this inventory service and this client. And so already see, all right, that's cool, But like underneath all of this, what you're going to have to build is the testing rig that allows you to validate this system. You're going to have, we're going to start out with just this inventory. We're just going to start out with something that can like create some stub data in the database and then create a fake client. And we're going to use a thrift client. And one of the reasons why, again, we kind of like are using thrift in this particular service is like the thrift client in C++ is just as good as the thrift client, and Python is going to do the same stuff. So we can just have like a little Python script running over here using the thrift client. And we can make requests to our stood up service, and then we can validate that things work. And that's essentially like what we're trying to do.